Hello, and welcome back to Educator.com. I'm Dan Fullerton, and in this lesson we're going to go over page 1 of the A+ Physics worksheet on electric field. And you can find a link to that worksheet down below the video. So take a minute, download it, print it out, see how you do, and then we'll use this video to check answers. So number 1, which diagram represents the electric field lines between two small electrically charged spheres? Remember, field lines run away from positives and into negatives. Well, number 1 can't be it. We're going into a positive. Number 2, we're going away from positives. That looks good. Number 3, we're going away from negatives and into positives. That's not it. And in number 4, we're also having field lines run away from a positive. Can't be it. So our best answer there must be number 2. Number 2, which graph best represents the relationship between the magnitude of the electric field strength, E, in a point charge and the distance r from the point charge? Well, remember, E, electric field, is the electric force divided by charge, which is K Q1 Q2 over r squared. There's the force, and we have to divide by that charge. So it's going to be KQ over r squared. Still an inverse square law relationship. So as distance gets bigger, we're going to go down by the square of the distance. So our correct answer here must be number 4. Number 3, the diagram below represents an electron within an electric field between two parallel plates that are charged with the potential difference of 40 volts. If the magnitude of the electric force on the electron is 2 times 10 to the minus 15 Newton, the magnitude of the electric field strength between the charged plates is, well, to get the electric field strength, that's the electric force divided by the charge, which will be 2 times 10 to the minus 15 newtons, divided by our charge, the charge on an electron, 1.6 times 10 to the minus 19 coulombs. And when I do that, I come up with an answer around 1.25 times 10 to the 4th newtons per coulomb. Correct answer there? Number 3. Number 4, we have two oppositely charged parallel metal plates 1 centimeter apart, and they exert a force with a magnitude of 3.6 times 10 to the minus 15 Newton on an electron placed between the plates. Calculate the magnitude of the electric field strength between the plates. Well, the electric field strength, again, is going to be the electric force divided by the charge, which is 3.6 times 10 to the minus 15 newtons divided by the charge. And we're doing this on an electron, so our charge is 1.6 times 10 to the minus 19 coulombs. So when I divide that using my calculator, I come up with something right around 22,500 newtons per coulomb, or 2.25 times 10 to the 4th newtons per coulomb. All right, one more here. An electron is located in the electric field between two parallel metal plates as shown in this diagram. If the electron is attracted to plate A, then plate A is charged. Well, if the electron is attracted to plate A, that must be the positive potential, and B must be the negative side. And we also know the electric field runs from positive to negative. And an electron feels a force in the opposite direction of the electric field, so it must be going up. So having figured that out, let's pick our best answer here. Plate A is charged, well, positively, so we can get rid of answers 3 and 4, and the electric field is directed from A to B. Number 1 there must be our best answer. All right, if these went pretty well, great, you're probably ready to try the AP problems. If they didn't go so well, now's a great time to go back and look over our full lesson on electric field. Thanks so much for your time, everyone, and make it a great day.